Hey, it's Miss Shannon. So this is just a little review for some stuff to remember about solving equations before we get started in our Algebra 2. Okay, so some things you should remember. Solving an equation means to isolate a variable. The reason we do it is just to get a variable by itself. So that means we can have many variables in an equation and still solve it. Okay. How we go about solving is we use inverse operations. Remember, we do if we add, we subtract. If it has division, we multiply, stuff like that. We also do them in the reverse of order of operations. Okay, so don't forget about that part. Then another thing you want to remember, we use properties of equality to keep things balanced. So that's that. Remember that phrase that you hear, whatever you do to one side, you got to do to the other. So that means if we decide we need to multiply both sides by 5, we got to multiply everything in that equation that is a term by 5. So be careful about using that distributive property, by the way. Okay, and last, one of the things I want you to remember is once the variable is isolated, that expression on the other side, it's what we call the solution. Okay, so the solution doesn't have to be like x equals 5. It could be x equals 3x minus, said it wrong. X equals 3y minus 2. Okay, or like when we're solving, trying to get an equation in slope-intercept form, y equals, 1/2 x minus 8, something like that. So let's get started. Okay, so starting with a simple one, 2 times x plus 8 equals -9. In my brain, I go, okay, I always multiply and then add when I'm following order of operations, so I got to go backwards, which means I got to get rid of addition first, so I subtract 8 from both sides. And I am going to kind of do this a little magically by just going ahead and say I am not going to show every single thing that I'm doing, but I subtracted 8 from both sides because -9 minus 8 is -17. Next thing I'm going to do, get rid of that 2, so inverse of multiplying, divide. So I'm going to divide both sides by 2, and remember, since -17 divided by 2 isn't exactly an integer, I'm going to go ahead and write it as a fraction. Let's avoid decimals for a while. So I get the solution as x equals -17 over 2. I can also write it, I don't really care. That's a good way to write it also. Just be careful about writing your fractions. And again, avoid decimals. Okay, so going on. That one over there, what's the trouble with it? I'm talking about this one right here. Yes, it has a variable on both sides, so remember how you do this. Okay, so we got to get variables on one side that we're trying to isolate, everything else that's not the variable we're solving for on the other. In this case, there's only one variable, x, so I'm going to get x's on one side, constants on the other. Does it matter which side the variable goes on? Absolutely not. If you like the left, you like the right, whatever you want to do. I'm going to go ahead and put it on the left. So that means I got to get this 7x term over here with that 5x. So 7x is positive on the right. I'm going to subtract it from both sides. So I'm going to get -2x plus 1 is -3. Now I want to go ahead and I need to get that 1 away from the -2x. So I'm going to subtract 1 from both sides. And that gives me that. Divide both sides by -2. And I get +2. Okay, so didn't mention this, but remember we talked about it's our solution. So that means, don't forget, you always want to double check your solutions just by going ahead and taking what you got as your solution, go back to your original equation, and then substitute. And you can do it in your head just to double check. 5 times 2 plus 1 makes 11. 7 times 2, 14. 14 take away 3, 11 works. And of course I could do that for the other side also. Okay, so, and now here we have an equation, and we're going to solve for y. Sometimes in Algebra 1 they call it literal equations. But, whatever. Solve for y just means get y all by itself. So, what do I got to get rid of in order to get y by itself? If I'm solving for it, I got to get rid of the 3 times x term, and it's going to stay together. And I just got to get the 4 away. So, I always think about working outside in. Outside means I take away that 3x first. 3x is positive. So that means on the other side, remember, it's going to be a negative. And since 20 is positive, I write them with a plus sign in between. And now I'm going to go ahead and I'm going to divide by 4 because I'm trying to get y by itself. Don't forget, I am going to show this one. I got to divide everything by 4 because that's the same as multiplying by 1/4, don't forget, which means we got to distribute it. So when I simplify, I got my fraction coefficient, and 20 divided by 4 is 5, and so this is how I would state my solution. Remember what we just basically did is we wrote it in slope-intercept form, so I would say like my slope is -3/4, and my y-intercept is 5. Okay, moving on. Let's go and do a couple more. Some things that trip us up happens to be fractions a lot of times when we're doing linear equations. And remember, a linear equation is when the variable that we're solving for has a positive exponent of 1. Okay, so this one over here, 3 times x minus 5, all divided by 2 equals 6. So a couple things I could do. I could go ahead and divide everything on the left by 2, getting 3 over 2 times x, minus 5 over 2 equals 6, and then solve for x. I hate that though. So I want to think about operations. That means if I was going ahead and I was following order of operations on this expression, well, what I would actually do is I would go ahead and I would take it and I would multiply the x by 3, then I would subtract 5, get an answer, and then divide by 2. Since divide by 2 was the last thing I did, it's the first thing I want to get rid of. So I'm going to go ahead and I'm going to take it and I am going to multiply both sides by 2. Since it says divide by 2, multiplying by 2 is going to cancel it. And 6 times 2 is 12. And now I have a super easy equation to finish up. So I'm adding 5, and then I'm dividing by 3. I forgot to write that. So my solution, x is 17 over 3. I kind of wanted to say boom, but I refrained myself. Oops, I guess I did. Okay, other one. Okay, so it's got that ugly fraction in it. Now this time, if I go ahead and I could just deal with it, I want to get the x's together, so I got that 2/3 x and that 5x, but it's going to just give me another fraction. So I want to do a little trick that just gets rid of the fraction completely. So I look at every term that has a fraction in it. In this case, I'm lucky I only have 1. And I look at the denominator, and the denominator is 3. And what I can do is I can use the distributive property to help me. Distributive property is your friend. Okay, so I'm going to multiply every single thing, every term, I should say, not thing, every term by 3, and let's see what happens. Okay, so if I go ahead and I kind of always just write it just like this. I just go this side and that side times 3. So I'm going to distribute 2/3 times 3. Well, remember that gives you technically 3 times 2, which is 6, divided by 3, which is 2, or we can just say the denominators cancel. And then I got to do 3 times -5, 3 times 5x, 3 times 4. So I end up with this equation, which is a lot easier to solve. Okay, so now let's do the rest. Should be pretty easy. Get the x's together, get the constants together, divide by -13, and I get -27 over 13. Okay, I did go kind of fast because I'm hoping that having done many of these equations in 7th grade, 8th grade, 9th grade in Algebra 1, even some in geometry last year, that this is familiar with to you. But if you need more help, just ask in class. We were going to do an activity to review it, but I think this should give you a little bit of a start about what you should expect to know at this point in time. Thanks.